CTW Automation here, and in this video we're going to continue to expand on our series of videos where we're talking about getting more out of your linear actuator, learning how to use the test sequence, the test builder, and adding commands so that you get as much as you need. Now in the first two videos we started with a very simple test. In the last video we added to that, keeping our same structure that we're always going to want to keep, and that structure was turn your axis on, turn it off, start recording, stop recording, a push gain or a performance gain, and a pop gain, a soft gain, and somewhere in here your actual speeds that you're going to run. Now this is the basic test, and we've expanded and added things that you don't have to have in order to run to complete a test, but they give you a lot more information that you can use in the future. Some of those are as a rehash. Edit fields, that's where we get our notes section in, and we learned that we load that through the start recording. And the set rod diameter, basically if you use if you want to figure out the internal gas pressure based on an estimation, you have to add this rod diameter, and that is what we use to give you your internal pressure for your gas force. Set your file name. You can tell it where to go. You can give it an initial name so that when the save as screen comes up, you already have some of the name written in there. Maybe it takes you less time to do it at that point. Now what we're going to talk about in this is the multi-point rod force as well as the export commands. So using that same test, we talked about the rod force. Now the rod force is just 1 point. But what if you have a motorcycle damper or a bicycle damper that are notorious for having components inside that add a spring force, and that spring force changes the more you compress the damper. Motorcycle forks, they have a spring inside unless you take it completely apart, and nobody wants to do that. You want to be able to measure that spring and remove that from the data. That's what this rod force multi-point does. And I'm going to drag it up right after that set file name so we can talk about the rod force multi-point. You can see it gets mad at you because it doesn't have any points. Great. We're going to add some of those points, show you how to use it. So there is the rod force multi-point. Now position start is going to be basically the top and bottom of how you want to test your damper. So if you want your damper to be tested over, let's say a 3-inch stroke, and you have already wanted to, let's say you want to be up a half an inch from zero, basically that enable axis up from there, we're going to make the start position 0.5. So that is basically the bottom of your stroke, and your, let me help you out so you can actually see. Look at that. So the position wave reversal, that would be the top of the stroke. So if you started at a half and you wanted a 3-inch stroke, then the top would be 3.5 inches. So that would cover the 3 inches of stroke, and you're a half an inch above zero. Now you can make that whatever you want, but that's the way you need to think about how this is going to operate. Settle time, that's how long it's going to settle every time it stops. Speed is how fast it will move position to position. And last but not least, the position table, 0 entries. Yeah, we haven't given any yet. So you could do number of points. If you do 3 and click it, it builds a 3-position table for you so that it will measure in 3 spots. Imagine that. If you go to 5, calculate, you will get 2 additional. Now keep spreading it out so that it's even increments, and hopefully you get a nice table based on that, and it will be removed from your data. We'll talk about that. Now you can certainly go to 7 if you like. It becomes a bit much, a lot of stopping, so we're going to go back to 5. So it's going to stop at each of these positions and measure that load cell on the way up, and then on the way back down it's going to measure the load cell, add those together at each spot, and it's going to generate, instead of generating one single point, it's going to actually try to generate a curve and it will basically remove the force based on displacement that your damper was measured at. So if you're closer to bottom dead center, you have less spring, static spring force, and you have a lot more closer to top dead center. It's going to basically be removing less force at the bottom, more force at the top to try to remove that spring from your data. So we're going to have 5. Obviously you can see that gets happier, and we're going to, actually I'll show you that now so it makes sense since we're talking about it. So that's the rod force, and this is actually what it will look like. So you can see this is our displacement trace, and I've gone ahead and done a diagnostic of the test. I actually collected it, did a diagnosis. So this is a displacement trace. So you can see position start, I have to type in 1/2 inch. This position start I think was 1/8 of an inch. So it starts here, and then it moves up, pauses for 2 seconds. That's that first position of the table. Pauses for 2 seconds. It probably takes a force reading right about there. Then it moves up to the next position of the table, takes a force reading right there, and again, you can imagine it's just going to move up and take a force reading at 5 spots. Now this is that reversal. That's the position valve reversal, trying to reverse the valve. And then it's going to pause again and do the same thing on the way back down. So it basically takes this force and this force, adds them together, and creates a point. Takes this force and this force, adds them together, creates a point all the way down, so that you're going to actually have, think of it as a, not necessarily a spring curve, but you're going to have a line, a curve of force increasing based on position, based on from bottom dead center to top dead center, removing more force as you go. That's what the displacement will look like. You'll actually watch your actuator go up, pause in steps, and then come back down. And that's way you can remove a spring from the data. So that's your rod force multi-point test. Now the next thing we will play with is the export all runs command. And again, we'll move that up into here. I didn't get the black bar, did I here? So you got to have the black bar. Export all runs. Now it's mad because you didn't have the format set. The software writers, software engineers get mad at you for that. So come over here and we'll pick one. Now what this does is automatically does an export of your individual test speeds to whatever file format you choose. Obviously you have Excel, direct to MATLAB, CSV, a JSON, or an XML. You can choose any of these. So that as this test runs, when it's all done, part of the saving process is to export these speeds directly into a MATLAB file format automatically for you. The name of those will be exactly what you type in as your save as. So they're just going to match it, and instead of a .CTW extension, it's going to have a .MAT or a .CSV or a .XLSX. Now, if you really want to have fun and you have a MATLAB engineer and you have an Excel engineer, you can have more than one of these in here. Now, let's see here. You can have one to MATLAB and one to Excel if you want. Becomes a lot of files at that point, but you can do this however you want. It is up to you, but that's how the export all runs works. And when you're done with the data, like I said, you'll have your CTW data file, but you will also have matching files for these speeds in these formats. Now, if you don't want to export for whatever reason all the runs, you can also use just export one run. So if you put this here, it will simply export the 10 inch per second run to an Excel or whatever you tell it to. So this is doing one file at a time, while this one does all the files in the end. So we'll go ahead and click that off. And I'll put this back up here. And I'll choose a JSON, which I'd never even heard of before, but I'm finding people that use JSON, so good for that. Now we know. So that is your test in this regard, and I'll show you what a test like this will look like. So again, I've run the test, and I have gone ahead and basically did a shock diagnostic of the file, and I'm looking at the displacement. Now, we did a start recording, which would normally be here, so you would never have this data, if that makes sense. So I did a start recording after the timed warm-up, but for the purposes of showing you what the machine's actually doing, I actually took this start recording and moved it to here so that you could see the entire test. You don't need to do that. That just adds data and time and file size to your test, but just so you could see. And if I could drag this over and make this a little bit bigger. So basically, we turned the actuator on, and I think this one might be a little bit better. Turned the actuator on, moved up, did that warm up, moved back down, did our multi-point, ran our speeds, moved back to 0, turned the actuator off. So that actually lets you see what the actuator did, positions, and let you know whether it did what you wanted or not, basically. So there's your test. You're going to save that. Again, saving it as some name that you can remember in the future, that you can find it. And again, like all names, even for your data files, the idea is not to remember it in an hour. The idea is to remember what it is in 6 months from now. What it is so that somebody else knows what the name of the test is. So the more information that's pertinent to the test, the speeds, what you did, multi-point, anything like that that's going to help some people. Or what most manufacturers are doing is they build these tests for specific damper types, and even specific damper types front and rear, so that they'll save that, they'll put that in the name so that anybody in the company can find and use that specific test. And I'll just save this. Yep, I'm going to overwrite it, and we'll go from there. So that's our test, showing you how to use the multi-point rod force as opposed to just the rod force, and how to use the export command so that you get the information out into a separate file format, because maybe you have to go to a database or right into MATLAB to start looking at the data in a different way. So there you have it. That's 3 videos. Look for them, work through them, and enjoy your actuator. See you later.